All right. So the main idea is to use all the rules we've done since the beginning of chapter 3. So we'll do power rules, product rules, and chain rules. It's just that we need to do it implicitly, right? So, for example, I think we did the first few. Uh, let's do number 5, I guess. So what we have to do is take the derivative of both sides of this equation with respect to x, right? See how it says dy dx. It's just that some of these functions have a y in it, so therefore you have to add an extra rule, which is the implicit stuff. Once you've done the derivative, you need to isolate dy dx or y prime, depending on the notation. And that's what we did last time I saw you, I think. Get this ordered here. All right. Let's do number 5, just to remind you. 3.6, no, 5. This actually was 5. Okay. Implicit derivatives. I'm hoping you guys have a good understanding of the chain rule and the product rule for these problems. So number 1, find dy dx given this equation, x times e to the y. So that'll be a product rule for this piece, minus 11x plus 7y equals to 0. So whenever you have an x, since we're doing derivatives with respect to x, then those are easy. But the y's are the ones that can be weird. So the ones that have y are not as easy. Okay. So what you're going to do is take the derivative. I'm going to use the ddx notation of both sides. So this side doesn't really do anything, right? Who cares? So here we're going to have to do a derivative of this, which will be a product rule. So that will be a little harder. So I'm going to write the notation, ddx time of this here minus ddx of 11x plus I'm going to move this over. ddx of 7y. Okay. So this one will be a product rule, like we said. So remember the product rule says you take the derivative of the first one times the second plus derivative of the second times the first. Where we had those formulas there, gave you last time. So derivative of the first times the second plus the first times the derivative of the second part. Right, that's basically the formula using ddx instead of the primes. Derivative of 11x, since it's just an x type, is going to be simply 11. Derivative of 7y, if it was an x, you would say just 7, but since there's a y in it, you would say 7 times the dy dx. So that's how you do the implicit derivative. So this part right here was a product rule, right? And then this is just the basic one, so now you're going to say it, right? This was all done implicitly, okay? So now derivative of x is just the 1. So it'll be 1 times e to the y plus x times e to the y, because derivative of e to anything is itself, but you have to multiply by the dy dx. You have that implicit rule. At this point, it's done. The calculus step is done. There's nothing. We have to do algebra now. Any questions as to where all this crap came from? You see? I know you guys might be rusty. All that spring break party. Right?
Not too much.
Yeah.
So why you put dx in the first part and then you put dy dx in the second one?
So this is the product rule right here. So let me write it the other way. Maybe it makes more sense. Remember we said if you had a function with 2 different pieces, right, f and g, the derivative using the other notation is the derivative of the first times the second plus the second times the derivative of this first, or sorry, backwards. G prime n. Right?
Yes.
So I'm using this. That's where this came from. Here. It's the same thing. So I'm just using the other notation because the book and the homework will use either one. Okay.
Okay.
Just so you get used to it.
Can you circle the answer?
Oh, we're not done yet.
Oh, I was like, I don't know which one it is.
There is no answer yet. We have to find it, right? We said find dy dx. So we have 2 pieces here that have dy dx. So you got to isolate these terms, factor it out, and divide the leftovers. So we're going to move everything that doesn't have dy dx to this side, right? So this piece stays. This piece stays. Everything else will go. So these 2 terms are going to go to the right-hand side. So add 11, subtract e to the y. Right, so add plus 11, both sides, minus e to the y, both sides. Gets us this. Once you've done that, you can factor this. Factor the dy dx, and you get x e y.
7.
Sorry, making sure I didn't make a mistake. Plus 7, yes, thank you. So we'll divide this part out, and then we have solved for dy dx. So dy dx is equal to, so let's show the division. So this is gone. So the answer is this. And I'll do it again with the other notations, so just so you can see it's the same. But is there any steps using this notation, or any questions about any of the steps with this notation?
No, I understand it.
So that very last one's going to be the answer, the 11 minus e.
Yeah. So if you look at the answer, they have, right? So at the very end, they divide this. I'll do it one more time, the same problem using the other notation. Because I know it's been a while since we've done implicit, right? The same question, same steps. So I'm going to take the derivative of both sides. So this time I'm going to use the quote as the notation for the derivative. Right. There's the quote. So that means do the derivative, this piece, minus the derivative, this piece, plus the derivative, this piece. And this is, of course, 0. Right?
Mhm.
Do derivative both sides, so we're done. So the derivative of this requires a chain rule, or sorry, a product rule. So this will be derivative of the first times the second, plus the derivative of the second times the first part, minus derivative of 11x, we know is 11, right? Derivative of this is 7, so you have to write y prime. That's the rule for the implicit. So now what is derivative of x? Yeah, it'd be 1, right? Derivative of e to the y. What is this one going to be?
E to the y.
Yeah, b itself, but then we have to tack on that extra piece, right?
Yeah, y prime.
Y prime. And the x is just showing it, doesn't do anything. So everything's the same so far, just different notation. So now we need to isolate y prime. So I want to move everything else that doesn't have a y prime to the other side. So I'm going to subtract this over to the right-hand side, add 11 to the right-hand side. So then I will leave us with ey y prime x plus 7y prime equal to 11 minus e to the y. Right? Plus 11 minus e to the y. So then we said last time, you got to factor out the part that we're looking for. So factor it out. Get e y x plus 7. And then you divide it out, right? Y prime is equal to 11 minus e to the y over e to the y x plus 7. The same thing, right? So that's the goal. You want to isolate the y prime or dy dx. So I think the same thing for all these questions here. All of them is the same deal. You take a derivative of each piece, both sides, and then you isolate dy dx or y prime. Whatever you choose to use, they say this, but this means y prime. So I would like you to get used to either one, because in related rates, we're going to be using this only in 3.6, I think, for the most part. But yeah, all this is the same deal. It's just that you may have to use chain rule. Okay. Do you guys have any questions on implicit derivatives? Do you remember?
I was having problems on number 7.
Number 7.
Mhm.
You want to do that one?
Yeah. Please.
Okay, we'll do this one and we'll move on to something else. Okay.
Um,
dy dx.
I guess
it?
for your problem, like the number 64 was throwing me off. Like we don't really like care, right, about that number.
Well, that number will be 0 in the first step, so it doesn't matter. But what are is yours numbers different?
Yeah, but I can still follow along. Like,
Okay. All right, so here we're gonna need a chain rule because we have a power outside and you have functions inside. So derivative both sides. So the derivative of the outside will be a power rule, but then we have the derivative of these sine and cosine functions. Okay. So here we go. This has a y though. Meaning we'll have an implicit piece right here. Okay. All right, so the derivative of both sides so this will just simply be 0. Because it's derivative of a constant, right? I might have to step further. All right, so I'm gonna bring the 4 down. Leave everything else the same. Subtract 1. Then multiply by the derivative of the inside. So this is the chain rule. So the chain will be done implicitly. So derivative of sine pi x, since that's just the x, derivative of sine is cosine. But then this has its own chain rule times pi, because there's a pi inside, plus derivative of cosine would be, actually, derivative of cosine is a negative sine, right? Times the derivative of the inside, which will be negative. Actually, it'll just be pi times dy dx. All of this equals 0.
Is that cube, the first part, the 4?
Yeah, so you bring the 4 down, subtract 1, so it's 3. We have 4 sine pi x plus cosine of pi y times, or to the 3rd power. Yeah, it looks like we're going to have to multiply this out. That's nasty. It's a nasty question. Okay. So this is what we're gonna have to do. So you see how we have a difference in the middle, right? Right here. We multiply this cosine pi whatever times this thing, and then subtract this, or sorry, multiply by the minus sine pi x or pi y, etc. Times that again. So you're gonna distribute this twice. So I'm gonna do that in not this step, but the next one. So I'm gonna put the pi in front, so it looks a little prettier. Minus pi sine pi y dy dx. Okay, it looks a little better, but not really. Before I can divide out, you see how this is a product? Four doesn't do anything.
Factor.
Let me double check before I go further.
Yeah.
Go to the inside.
Okay. Derivative.
Here, that's this. I think it's good so far. So divide both sides by 4 and it's gone. Because 0 divided by 4 is 0. So the 4 does nothing. So let's just stop writing it. So I'm going to distribute this entire cube thing into both of these pieces. Does that make sense? So here we go. Pi cosine pi x times this nonsense. Sine of pi x plus cosine of pi y cubed. And then again, minus dy dx sine. Let's put the pi. Pi times sine pi y times this sine pi x plus cosine pi y cubed. And it's still equal to 0. I'm just running out of space. So I'm going to move the piece that does not have the dy dx to the right hand side. So this first piece will be moved over here. You guys still follow me? It's getting messy.
Yes.
Okay, so I'm going to do this whole thing by subtraction over here. Okay. So subtract this, and you get negative dy dx pi times sine pi y times that cube stuff sorry, just double checking. It's very easy to make a mistake here. Okay, so that's this piece. I'm moving that one. Negative pi cosine pi x sine pi x plus cosine pi y cubed. 0 is in the way now. So you see how this is on the same thing on both sides, right? The cube stuff.
Mhm.
You can divide both sides by this. So this will cancel. You can cancel both of these right away. So in the next step, we don't have to write that anymore because it's 9. So now all we need to write is this piece equal to this piece. Right? Do you see that?
Yes.
Now, this is what I did, in case you don't follow me. 2x equal to 4x, and divide the x out, right?
Mhm.
That's what I did. This is just some big X nobody cares about. It's gone.
Okay.
So then divide this out, and we've solved for dy dx. So in this step here, divide both sides
um,
by negative. So we cancel the negative. So that's gone. So now dy dx is equal to these pi's cancel. That leaves me with cosine pi x over sine pi y. Finally.
Mhm.
Now, is there any step that I lost you at? So the algebra got kind of funky.
Can you move it down just a little bit, please? Thank you.
Yeah. Make a note for you.
I got the right answer, but I think I did the algebra differently.
What'd you do?
yeah.
If I explained it to you, do you think you could tell me if I did it right or?
Sure.
So for like that part where we did like we multiplied a bunch of different parts. The four, the one at the top of your screen.
Mhm.
Instead, I divided it on both sides, and then it was set to 0. And then I moved one of the signs to the right side, and then or I went when I moved something. Sorry.
No, I follow you. I see what you did. That idea is tempting and it works sometimes, but there's a possibility that dividing that out with the 0 may cost you a solution.
Mm.
So I distributed just to be safe, even though it was more work, because it's possible that it won't cancel. It just so happened that I had both of them on the same side, and I got lucky. If this were not to have happened, then it probably would not have worked out. So it really depends on what we're doing, what we're talking about. Sometimes, yes, you can divide stuff out, but I'm very hesitant to divide anything with a variable because it might be part of the solution.
Okay. Thank you.
Okay.
All right, guys.
Can I see your number 16 really quick? I don't know if it's the same.
Which one? Six? I didn't do 6. I did 5 last time.
I mean, like your number 16, because it's like an infinity sign. It's a
Oh,
graph.
the graph. Yeah.
Yeah.
I think it's Lemniscate.
Oh,
So you take on this one, you just take the derivative of this function, and then you plug in the x value to find the slope. So you're going to get this piece. Once you have the slope, you plug in the 2 to find this piece.
is it gonna be the same for the other ones too?
Yeah, it's the same. We've done stuff similar. We've done the equation of tangent line a few times already. It's just now the derivative is a lot harder to get, but the steps are the same.
Okay.
So we find the derivative and then plug in that x, just like the last couple of sections. If that section feels difficult, it's because you haven't mastered the sections before it. So it'll get easier as you practice. That's why there's a ton of problems to force you to practice. Let's see here.
just a random question. Well, not so random.
Mhm.
But I saw you put the dates on the homework. Is that tentative or?
No, I don't even remember what I put. I just tried to put everything open during spring break. I need to go back and check what closed and what's not still open. I know chapter 2 is done at this point, but
Mhm.
I'll probably move or open some of the most of the 3 still.
Okay. Because I think like you have 6 of them due for this Friday.
Yeah,
I
I
know some
moved
of
them
it's
all.
chapter 4, and I'm like,
Yeah, don't worry about that. Well, as long as you are where we are, we're good. It's just the whole dates are messed up because of that week we took off. But it's okay. Okay, let's go derivatives of inverse functions. Give me a second. Yeah, all right, here we go. I'm gonna give you the theorem that we're gonna need. The continuity and differentiability of inverse functions. This is theorem 3.16 in your book. Continuity and differentiability of inverse functions. Okay, so let f be a function whose domain is an interval which we'll call I. If f has an inverse, then the following is true. Number 1.
What does that say at the beginning of this phrase?
Right here,
Right there.
so 3.16, the weird 6. Continuity and differentiability of inverse functions.
it says the 3.16.
Theorem, THM.
Oh, there.
So theorem 3.16 from your book. So we're going to write a couple of theorems and then we'll start some examples. We will need to refer to them. That'll be easier. So if f is continuous, on its domain, then f inverse is continuous. on its domain. Okay, number 2. If f is differentiable, meaning you can take the derivative. Differentiable on an open interval containing C and f prime of C is not equal to 0, then f inverse is differentiable at C. So if f is differentiable on an open interval containing C and f prime at C is not 0, then f inverse is differentiable at C. Okay, so that's 3.16. Let me give you 3.17. Theorem 3.17. The derivative of the inverse is the most important one for this section. Function. Okay. So let f be a function that is differentiable on an interval I. If f has an if f has an inverse, inverse function, which we'll call g, then g is differentiable at any x. I wrote differentiable all weird, but whatever. Okay, any x is this, for which f prime of x, I'm sorry, differentiable at any x for which, yeah, this is we got this last part. 1 second. This is wrong. Should be which f prime of g. Yeah, there we go, is not equal to 0. So basically, keep it all simple. What I'm saying is this: g prime of x, meaning the derivative of the inverse, is equal to 1 over the derivative of f of g, as long as the derivative of f of g is not 0. this is the formula we're going to be using in this section. So basically, if you can take the derivative of f, the inverse exists, then that means you can take the derivative of the inverse, and it would be equal to 1 over the derivative of composed with its inverse. So this formula right here is what we're going to be using. Okay. But in order to use it, they have to define it with all this information. Okay. All right. So let's look at the homework. Let's go to the book phrase there. I think another way to say this, to make it a little more simple, at least in my mind, would be to say the derivative of f inverse, derivative of this, is equal to 1 over the derivative of f inverse.
What did you write on the left side? I
I.e., yeah,
okay.
I'm just rephrasing it. So, what was he doing? Yeah, that's right. So the derivative of the inverse is equal to 1 over f of f inverse after you take the derivative. Okay. Yeah. I think this makes a little more sense. It just looks messier, but these are equal. Okay. All right. Let's find an example so we can all make sense of this. It's not a good one. Oh, I see. Yeah, the majority of these questions are derivatives of inverse trig functions, which really is going to be formulaic. The first few, though, is testing you on the theory of this definition I wrote down. The first couple. But first, let me give you the inverse trig derivatives before we start. I sent you a formula sheet, right? For derivatives.
No.
I think he emailed it. Yeah.
Did it have the inverse trig on there? Derivatives of inverse trig. Let me find it. Oh, I'll just write them down for you. Well, they're on the sheet, but just in case, I'll give them to you here from the book. They're on 3.18. Derivatives of inverse trig. So this is the stuff I want you to focus on in this section. So the derivative of inverse sine. In the book, they use the word arc sine. It's the same as saying sine inverse. So I'm going to write it both ways the first time so you know the difference. That there is no difference. And you've seen the symbol before, right? Sine inverse. Back in pre-cal. It's the same as arc sine here. It's just that the -1 can be confusing because we think it's a power, but it doesn't always mean a power. It means inverse in this case, which I think is confusing. This one's better because it's clear. This means inverse. There's no doubt. But anyway, so I'm going to use this one the whole time. Arc. So the derivative of the inverse sine function is going to be derivative of the top part, the argument, over the square root of 1 minus x squared. Okay. Derivative of arc cosine or cosine inverse. Same thing. Going to be negative x prime over the square root of 1 minus x squared. The derivative of tangent, arctangent, will be x prime over, where is it? Yeah, that's right. 1 plus x squared. Derivative of arc cotangent will be negative x prime over 1 plus x squared. derivative of arcsecant. Will be x prime over the absolute value of x times the square root of the x squared minus 1. Last one, derivative of arc cosecant. Okay. That will be negative x prime over the absolute value of x times the square root of x squared minus 1. And when I say x prime, I mean you take the derivative of this, whatever this argument is. In this case, it would be 1, right? You see that? This case would be just a 1. But let's say that was 3x, then this would be a 3. Or if this was x squared, well, that would be 2x. Anyway, so remember what the prime means, take the derivative of this argument here for all of them. All right. Let's go to the homework for real this time. So to make sure we have that information. I'm 90% sure you haven't seen the videos yet. Of the spring break. We'll start with 6. I'm probably going to remove some of these first ones, so don't worry about those for now. So number 6, take the derivative of the arc sine. In other words, sine inverse. Okay. So this section won't be too bad.
I'm sorry, can you flip it to the other page? I didn't want to take a picture because I wasn't done copying.
Oh yeah, that's fine. There's no rush. The top part.
Okay, I got that part. Thank you.
Yeah. And I'll send it to you as well. No worries. As soon as we finish. Define the derivative. So this section won't be as bad as the implicit stuff. We just have to use this formula. That's it. So arc sine of x minus 3. The derivative of this would be equal to, the formula says, derivative of this top part, right? The argument was in the top. Derivative of whatever's in here is up top. Then you do 1 minus x squared, where x is this. That's how we're going to do. Nothing fancy, right? So it's equal to the derivative of this thing over the square root of 1 minus this thing squared. What is the derivative of the top, the numerator?
One.
Yeah, it's just a 1, right? So now square this nonsense and organize it and you're done. You get 1 minus x squared minus 6x plus 9, which gives us 1 over negative x squared plus 6x minus 9 plus 1, which will give us the answer, right? It will simply be this. negative x squared plus 6x minus 8. Are there any questions on how we use the formula?
So it's very much just plugging in the value and
Yeah.
not much. Yeah. Wow.
Yeah, the entire section is just be just using the formulas, so it's not too bad. It's just at the beginning, there's a lot of theory to explain the derivatives of inverses, which is interesting and important, but as long as you know how to use the formulas, you can get through all of these guys. But remember, they're going to bring up stuff from the other sections. They're going to bring up chain rule, product rule and chain rule. So you'll be using this new formula, but you still have to remember everything that we've gone through in chapter 3 except for implicit, because implicit does not seem to appear here at all. Yeah, there's nothing here. And these first few I'm going to remove. I'll keep 1 or 2 of them for you so you can see how the definition works, but you don't need 5 of them. Let's do another one. Let's do number 8 and number 9. Those look challenging. All right. Define the derivative. Three arc cosine x over 7. So I'm going to write it again over here. 3 arc cosine of x over 7. So the derivative will be, right, let's look at the formula again. It's the same as the sign, except you put a minus on it. It's the same as this. So minus derivative of the argument, square root 1 minus the argument squared. That's all we're doing. So what is the derivative of x over 7? Right, it's just the same as 1/7 x, correct? What is the derivative of x over 7?
One
Indeed.
seventh.
Yeah, this is going to be the 7th. Then down here we got to do some fraction stuff. This will be x squared over 49. Add these together, and we're almost done. The 1/7 looks weird. I forgot about that 3. Should be, technically it should be in the front, so I'm going to put it here. Should be right there. The 3 doesn't change anything, it's just in front of this question. So just multiply it in. Okay. All right, so we have 3/7. So that 7 looks weird, so I'm going to put it down here. That's the same thing. You can subtract these by combining the denominator. Right? you can square root the denominator, but not the top. So this will come out as a 7. So negative. So you have a 7 right here, and a 1/7 comes out, leaving you with 49 minus x squared. So these are gone. So finally, the answer is this. So the question wasn't difficult, it was just very algebra intensive, right? It seems to be a theme. The calculus is not hard, it's the algebra you're required to know can get hard. Any questions about any of the steps? Do you see how we use the formula right here? From here to here, we use the formula. This is the calculus step right there. The rest was just playing with algebra. Are there any questions on number 8? You guys feel okay about this section, or?
Where did we get the 1/7 coming back? That canceled out the 7?
Oh, okay. Right here, you see there's a 49 down here?
Yeah.
Let me write an extra note here. So what we have right now is this, right? 49 minus x squared over 49. So you can separate the square root using our radical rules, right? So this becomes a 7. So the 1/7 just comes out from the bottom. By square rooting the bottom, you're pulling out at 1/7.
Okay.
You see it?
Yeah.
Okay. So then that gets rid of that other one. So we're good at that point. All right. We'll do one more and I'll let you guys think about this for a bit. I feel like you need to digest and watch those videos. And we can go over some homework questions too, if you like. All right, so this will require a product rule. So you got one function and another one. So the derivative will be the derivative of the first, all right, which is just itself. Well, let's write the formula first, I guess. The derivative of the first times the second piece plus the derivative of the second piece times the first piece. That's our product rule formula. Derivative of this first piece is itself, right? Times the chain rule. What does the chain rule say? You see how there's a 3x up top? You're gonna have to do the derivative of this inner function. So technically, if we show more steps, we will have this. Derivative of arc sine, which we already know by the formula, is going to be 1 over the square root 1 minus x squared times this. So that will give us this here. At that point, the calculus step is done. All we can do is pull out the E3x. Maybe we can make it look prettier, but it's done at this point. You can factor this out, leaving 3 arc sine plus 1 over square root 1 minus x squared. This is what they got here. You guys have any question number 9? Okay. You guys have any homework questions from this section or the previous piece, or anything or chapter 3? Doesn't matter.
I have a question.
Yeah, which one?
On 4.2.
4.2?
Yeah.
All right, let me see. No, which question?
So I was just wondering, like for whenever it says like f(x) equals 0,
Yeah.
we're supposed to find,
Was that one more time? Sorry, you cut out.
or I said how we're supposed to find it.
Let me see.
I was able to find the one I told you about, but I was having problems on the other 2 questions.
You're talking about finding when the derivative is equal to 0? Is that what you're talking about? Or the regular function?
Not the derivative.
The only way you can find it would be find the derivative, set it equal to 0, and use all the algebra techniques you can find. It really depends on the question that we're talking about. Could be quadratic, could be just solve for x, could be something weird. Let's see here. So the mean value theorem and Rolle's theorem, right? All right, so derivative of this part is no big deal. That's just a -8, right? This is just going to become a -8x, but we need to change this guy into x plus 1 to the 1/2. And we're going to take a derivative of this. It's going to bring the 1/2 down, and then times the derivative of the inside, which is 1, so it doesn't really matter. The chain rule doesn't make a difference in this case. So you're going to bring the 1/2 down to be -8 times x times the 1/2 times the x plus 1 to the -1/2. So I subtract 1, right? See how we did the power rule down?
Yes.
Okay. Now, you had the 8 factored out. I have it inside still. Doesn't make a difference, but I'm going to go ahead and pull it out just so it's the same. So we have, so this is negative, so I'm going to take it down to the bottom. You're going to have minus x over this 1/2 is where the 2 comes from. X plus 1 to the 1/2. You see what I mean?
Okay.
So it's not always a 2. That came from this power, came down. And then they changed this back to a square root. And that's what they did. So they said this is just square root. See what I mean?
Okay, yeah. That's where I skipped them.
So then you need to combine these fractions. So I need to multiply the top and bottom by this to be able to add them.
Okay.
So you would get x2 times x plus 1. Oh, let me show you this stuff. So you multiply the top and bottom by this. So you can have the same denominator as the one as this one here. Okay. Then in the next step, you can add them. So we will get, I don't know if I have enough space here. So the square roots will cancel, leaving you with a 2 times x plus 1 over 2 square root of x plus 1 minus x over the same denominator, 2 over x plus 1. So now you can add them, which I'll have to do in the next page because I'm out of space. So that'd be 2x minus x, which would be 1x. It'll be 1x plus 1 up top. Let me write that again, so I will forget. Let me rewrite that part again. 2x plus 1, 2 square root of x plus 1
Money.
minus x over 2 square root x plus 1, right?
Yeah.
Okay. Okay. So then this becomes 2x plus 2 minus x over the same denominator, right?
Yeah.
2 minus 1 gives us x plus 2 over 2 times square root of x plus 1. So now you set this equal to 0, right? And this is, so this is how you find the derivative, right? That's the first step. And then they ask, where is the derivative 0? So set this to 0, so that'll get us here. So divide by -8. So x plus 2, 2 over square root of this nonsense. All right. What was their answer? The -2?
My answer? Or what do you mean?
Yeah, what did they get for their derivative? The last part. Oh, you don't have it.
No, I don't have it.
Let me see. They put -8/3.
Oh, that's what I put, but it's not right.
I think it's -2. How many tries do you have?
Oh, I don't know. Let me see.
Let me double check everything.
Oops.
2 + 2. Double check everything.
No.
All right, hold on. You had -8x plus 1. Derivative. Then
These take a lot of work.
oh, hold on. I think I forgot something. I'm sorry. What were you saying?
I said that these take a lot of work. I was
Yeah,
like,
it
oh,
can.
questions, no problem. Yeah.
Let me check something. Hold on one moment. Let me double check my derivative. If that's wrong, then the next step doesn't make sense. Yeah, I made a mistake somewhere. Okay. Oh, I factored -8 out, so this should be plus, plus, plus. God damn it. Plus, which means this would be plus, which means this is plus, which means this is a 3, and a 3, and a 3. There we go. Sorry, I made a sign error. So you set, so basically you just, once you find the derivative, you set it equal to 0. The only way this will be 0 is if the top is 0, right? Because the bottom
Okay.
makes no difference. So let's solve this. X would be -2/3, right?
Yeah.
So that should be the answer.
Let me see.
I'm going to sleep.
Huh?
That's wrong. I'm going to sleep.
Oh my god. You better not. Oh, okay. Yeah, it was that.
Yeah, the idea, right? I feel like we get bogged down by loads of algebra. All you have to do,
Yeah.
take the derivative, right?
Uh-huh.
You have it. You
Yeah.
set equal to
Right.
0, and it's it. It's just that getting it can be annoying. As we're seeing that some of these derivatives get more and more complicated and require, more work.
Yeah.
Okay.
Okay. Well,
It's
they.
Yeah, no problem. Just about out of time though. you guys have any last minute? We don't have time for the problem, but did this last section make sense? The derivatives of inverse functions. Isn't too bad. I hope.
Yeah, not too bad.
Okay. And please review if you've forgotten the chain rule, product rule, all that stuff. Because it's going to make the later sections a lot harder if you haven't grasped it yet. Excuse me. All
All
right,
right,
guys.
sir. Okay,
You guys
good
get
night.
some sleep.
Yeah,
I'll see you later,
I'll see you on Thursday, Wednesday.
Thursday.
All right, sir. Good night, guys.
Right, hey.
Have a good night.
You too.